Hello, welcome back. In this video I'll be demonstrating how to configure a port on an ACE3600 series CPU as a MODBUS slave port. Let's begin by right clicking on the site and selecting view. Click on the port, click and select the ports tab. Click and highlight serial interface 1. From the media drop down, select RS485. The connection type is third party protocol. The connected setting defaults to master, and this is what we need. For this instance, this is what's required. The port name, we have a selection, PLC 1, 2 or 3, leave it at PLC 1, and a data speed, again from the drop down, depending on your application or needs, here you select the appropriate speed. In our instance, it defaults to 9600. Next, click on the advanced configuration setting, and we have 3 tabs. The first one is physical. The only one we really need to consider here is our UART character format, and we just leave that as default, which is 8 bits, no parity, 1 stop bit. The next tab is link. There are no settings here to change. Next is our PLC master settings, which I strongly recommend you consult the third-party protocol manual that's included with the system tool suite package. And that's quite a comprehensive manual and goes into great detail explaining what each of these driver specific parameters do. Don't change anything here unless you're actually told to or instructed to. For the benefit of this video, we'll be just leaving everything as default and just select OK here in this instance. Okay, next we click and select the General tab. We need to associate a driver file for the MODBUS slave port. Select Add-on Manager. Click PLC 1 to master. From the available file types for ACE3600, you can see the file types and the available RTUs or CPUs here. We want ACE3600 and we want PLC 1 to master. Browse and import. There's the file we wish to associate with the project. Click open. Next, select the site that you wish to associate the file with. So in this instance, it's site 6. Click OK. That completes the MODBUS slave file association with the site. That file will be included with the site configuration when we're ready to download. Next, we need to assign this site an application, and as there is no existing application, we need to create one. Click Assign Application. On the left here, select New Application. Let's give this a name. We'll call it MODBUS Slave. And OK. And as you can see, the application programmer window opens. The next step, from the database tab, click and expand on the system tables. Navigate to the PLC table, which is here. Double click on that to open, and we enter in the PLC address or the slave MODBUS address we wish to use. In this case, we'll leave it at site 6. We'll make it 6. Connect it to RTU via local, which is the only option there, via port RTU as PLC. So we've completed configuring the MODBUS address, MODBUS slave address on our RTU. So we've made it site 6, MODBUS slave address 6, connected to RTU local, RTU as PLC. These columns stay as they are, that's fine. Next, we need to define some user tables, some user database tables. So right click on user tables, append table, select single multiple column table. Table name, we'll start with discrete, we'll keep it simple. Discrete table symbol, we'll just call it DI. Table type, we'll start with single columns because there is something I want to show you. And data type is discrete. Okay, that's good. Now, last index will make 4. Now, to be able to map this data back into a MODBUS master, we need to work out what the addresses are. And here is a formula that MOSCAD provides us with. So, ACE3600 data is mapped into the MODBUS database by using the following default formula, where Z is the table number. So if you down here on the right hand side, you'll see we have that information there. So Z is the table number, so in this case table 1. X is the column number, which is 0, and Y is the row number, which is 0. Okay. There is an offset, but we're not using the offset here. We're not applying that offset here. So, for example, in this instance, we'll just give these a name. We'll call them D1, D2, D3, D4, and D5. Oh, D5. Okay, so they're our discrete register names. So let's work out what our first address is going to be. So the first address is going to be table 1. So it's 1 times 2048 plus the column. So the column number is 0. 0 times 256 plus our row number, which is 0 in this case. And that will equal, I'm hoping, 2048. I'm just going to work that out because it's a sec, which it is. So that's our first register address is 2048, and we can prove that, and we're going to use MODBUS to prove this. So with our first register worked out as being 2048, the subsequent registers will be 2049, 2050, 2051, 51, and 2052. They're going to be our MODBUS addresses, and we'll prove that now. And here we have it set up. We've got our MODBUS, and we have it set up. There we go, 9600. Our format here, and our MODBUS request information. So slide ID 6, function code reading coils, start address 248, number of coils is 5. We send, and it looks like a successful send. Now we'll just enter a bit of data in here. We'll write a 1 to all these. So we'll just update the MOSCAD CPU. Okay, and we'll send. There you go, and it's updated here. And we'll turn these off. And we'll send again, and there's that one off. So register 252 is off. Oh, I have to update it first. And we'll send that one there. There, 0, that's updated, 251. And we'll send this again. So that's definitely reading, definitely updating. Next, we'll set up a value input or a real input, just to give you an idea of how to apply that formula, which is for creating the register mapping. So in the same way that we added the discrete table, we'll just close this one down. So in the same way we added the discrete table, we select user tables, right click, append table, select single multiple column table. Table name, we'll call it value. Oh, value in. So we'll just call it VI. And it's a single column. Now from our data type, you can see here we've got quite a bit of in the data types. So we want value input. And there's a value input, and we'll select OK. Last index, we'll give it 4. So we're going to read five registers there. So we'll call this value input 1, value input 2, value input 3, and value input 5. There we go. Okay, so again, using the same formula. And there's our formula. So we'll just work this out. So we know. So it's in this case, it's so the ACE3600 data is mapped into the MODBUS database by using the. Okay, so here we go. Table number. Our table number is 2. 2 times 2048 plus our column is 0, so 0 times 256 plus the offset, which is 0. Okay, and that will be, in my reckoning, 4096, I hope, which I'm pretty sure it is. So let's set this up using ModBus to confirm this. So we'll just compile this and we'll download it to the CPU. Here, we'll just compile that and we'll download that to the local CPU. And we'll set up ModBus to poll those tables. In here we have ModBus running. Again, the only change we've made is the function code. So we're reading holding registers and the start address, and we'll send that data, and it's not throwing back any exceptions, which is great. Next, we'll input a bit of data into these tables. Okay, we'll put in 100, 150, 200, 250, just some random numbers, and 300. We'll update the RTU. There, and we'll send. And that data appears here. You can see we've successfully read the registers, and our mapping is working is working correctly. So that's how you work out the slave mapping. Next, we'll set up a multiple column table, and we'll apply the same formula, and just to show how this formula works. So we've demonstrated how to apply this formula to work out the ModBus registers, or the ModBus register or bit addresses we need to get the addresses into the ModBus master. Next, we'll use a multiple column table or a multi-column table. So let's begin by right-clicking on on user tables, a pen table, and we'll call it test. That'll do something original, not table type. We'll just call this test 1. Table type, multiple column tables, and hit OK. So first column name, we'll give it a name. We'll make it digital outs. That's a discrete, and we'll do 5. We'll do 4 again. So we're reading 5 registers. We'll append column. So right click here, and we can say append column or insert column. We're going to append a column, and we'll call this value input. And we select the data type as being value input, and OK. And there you go, we've got those two here. So as we add columns and as we add rows, you'll see these numbers here incrementing. So let's apply the formula, and here we go. So we want to be able to read our first column, so here we go. So we know that it's table 3. So here we go. The Z is our table number, so our table number times 2048 plus the column number, which is column 0. We'll say column 1 this time actually, because I'm interested to read that one. Plus 1 times 256 plus, there's no offset, and that will equal, and that equals 6400. Okay, we just confirmed it. So our first register, the first value input register will be 6400. We'll check this using ModBus. Let's compile this. There's no errors, or there's 4 warnings, but we won't worry about that. We'll download this to the local RTU and ModBus RTU, and we're ready to monitor. So we've successfully updated the local RTU, and we've got our ModBus ready to read register. We'll start putting some numbers in here, start plugging some numbers in, just some random numbers. And we'll see what happens. So we'll just update the RTU. Now we'll send a request to the ModBus slave RTU, and there we go. And there we have our corresponding data read back in ModBus. So that's how we set up a ModBus or a MOSCAD slave RTU, by using this formula here. Now this formula is well explained in the third-party protocol handbook that's included with the STS, which, like I said earlier, I thoroughly recommend that you read, because it contains a lot of information, goes to a lot of detail, and there might be some extra features that you need to use or apply. I thoroughly recommend that you read that manual if there's any more changes you want to do. This is a really basic setup. It's just a bit of an introductory setup just to demonstrate how it works. Okay. As we move along, as we progress with these videos, I'll set up a very basic or a very simple RTU to RTU setup where we have a MOSCAD device acting as a data concentrator, reading a MODBUS slave RTU, in this instance another MOSCAD acting as a slave, or a MODBUS device, and we'll have a MOSCAD acting as a data concentrator. That'll be in a video coming up soon. The third-party protocol manual can be found in here in STS manuals. So if you double-click STS manuals, as I mentioned, again, I'll keep mentioning it, these are very comprehensive manuals that I thoroughly recommend you read to get a better understanding of what's going on. And here we go, there's our third-party protocol support manual. It covers ACE3600 and ACE1000s. I will cover ACE1000s in the near future, particularly for MODBUS setup and for just general configuration setup. But for now, all the information required to do MODBUS master on ACE3600 or MODBUS slave on the ACE3600, all that information is in here, in these very comprehensive manuals.